Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about counter. So I request everyone to watch the complete video for better understanding. First, let me discuss what is the use of a counter, and then I will discuss what are the different types of counters. Counters are used in digital electronics for counting purpose. Let's take that you went to a EVM voting. Let's take that elections are happening on a day. Then usually on elections we will use the EVM machines for counting. Am I right or wrong? Suppose some first person has won and he entered his vote. Second person has entered and he has given his vote. Like that everyone has given their votes. By the end of the day, you want to see how many persons have given their votes. They'll say how much percent of polling has been happened. How they will do? They will use the counter there and it will count 1, 2, 3, so on. By the end of the day, it will give total number of votes were polled by using that EVM machine. So there we can use the counter. Wherever we want to do some counting, then we will use the counters. Counters can be ascending, means increasing order 1, 2, 3, 4, so on, or they can be descending, meaning is that n minus 1, n minus 2, so on up to 0 it can go, or we can even design a random counter like 0 to 3, 3 to 5, 5 to 1, like that also we can design a random counters. All these things I will discuss in detail, don't worry. And another important point is for a n bit counter, we need n flip-flops. Am I right? Already we have discussed several types of flip-flops such as SR, JK, T and D flip-flops. Now if you want to design a n bit counter, you need n flip-flops. So if you want to design a 3-bit counter, you need 3 flip-flops. And another important point is that a n bit counter contains 2 power n states. So if you take a 3-bit counter, 2 power 3, 8 states will be there from 0 to 7. Okay, are you able to understand? And counters are broadly classified into 2 types. One is synchronous counter, another one is asynchronous counter. Now let me discuss what is a synchronous counter and then I will discuss what is an asynchronous counter. As I said, for a n-bit counter we need n flip-flops. Let's take that. I am taking a 2-bit counter. So then I will have 2 flip-flops. Okay. If these 2 flip-flops, we need a clock. If I am giving a common clock for these 2 flip-flops, then I will call it as a synchronous counter. Are you able to understand? We will use some flip-flop. Am I right? We will have Q0, Q1. We have let's take that I am using the D flip-flop. I will have D0, D1. These are the 2 flip-flops I am using. And they are interconnected. How we bother later, but I am talking about its clock. If they are using the same clock, then we will call it as a synchronous counter. Okay. Now we'll discuss about the asynchronous counter. Let me take the same 2-bit counter. Okay, I have 2 flip-flops. Okay. Now for first flip-flop, I will give the universal clock from the external source. Okay. For the second flip-flop, the output of the first flip-flop will act as a clock for the second flip-flop. Are you able to understand? In the synchronous counter, the 2 flip-flops we are given the common clock. Am I right? Whereas in asynchronous counter, the first flip-flop will give a clock. The output from the first flip-flop will act as a clock for the second flip-flop. Let me take, I am using a T flip-flop. This is T0, this is T1, okay, and you will get a Q0 here. Now this Q0 is the output. Am I right or wrong? This output of this flip-flop is acting as a clock. Then we will call it as an asynchronous. Suppose similarly I have another flip-flop here, T2, okay. Now output of this one is acting as a clock. Then we will call it as an asynchronous counter. So the first flip-flop we will give a clock and from the next onwards the output of the previous one will depends on the clock of the next flip-flop. Such kind of counters we will call it as a asynchronous counter. And remember one thing, the synchronous counters are faster as compared to the asynchronous counter. Why? Because the delay, the total delay will be depend on the delay of each flip-flop, because if this flip-flop has to be enabled, it has to get the output from the previous flip-flop. Then only it can be enabled, because then only you are getting the clock here. I hope you have understood what is a counter, how many counters are required, how many flip-flops are required if you want to design a n-bit counter, and how the counters are broadly classified into synchronous and asynchronous, and what are they. All these things I hope you have understood. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as soon as possible. In the coming videos, I will discuss about the synchronous counters, then I will discuss about the asynchronous counters. Thank you for watching my video. Have a nice day.